reduce the theory completely is kind of exaggerating. I mean, there was this change that occurred which did kind of relate to the ether, but it's not as Tom Bearden describes. But the thing that is curious though is it is true that if you do use the quaternions or the biquaternions, the complex quaternions, then you can get an additional term in Maxwell's theory that is the so-called off-shell formulation of QED. And Richard Feynman has studied this. So there is mathematics that uses quaternions. It's just not exactly what it didn't work out exactly as Tom Bearden says. So I think Tom Bearden must have seen two different things and almost assumed they were the same thing, but it's
I
not
think you're right about
exactly
that.
true.
I mean, I don't know why Bearden didn't know this. He either didn't look hard enough and actually run through the algebra, or who knows what he was thinking or trying to do. But yeah, look, quaternions are people have tried to do quaternion quantum mechanics and quantum field theory, and they've tried to do all kinds of things, but that's kind of separate. That we're just talking classical electromagnetism here, and the whole thing about I think that Bearden, uh, he was certainly not correct in his discussions
Agreed. Yeah.
math. As to whether he's correct with all his, he's also not correct about why the space shuttles, the Challenger accident happened. Okay, so he tried to say that the Russians shot a scalar wave beam through the Earth and blew up the space shuttle, and it's like, no, I don't think so. So I kind of think, like, as far as I was concerned, Bearden is pretty close to violating my three strikes and you're out rule, which is, after you've made three claims that are easily refuted, I don't really have to pay much attention to your claims anymore. Anyway, that's all.
Well, Creon, thank you. Thank you. No, I appreciate you sharing that. So let me see. David, were you all set?
Oh, yeah, I'll just mention that I believe on June 8th, I'm going to give a talk that I'm going to go into a lot of this mathematics. And yeah, I'll just mention that, that off-shell formulation of QED, I mean, it gives you classical field equations. Like you add this gauge fixing term to the action, you can get classical equation of motion that add longitudinal modes. And so a lot of people have studied this kind of in the fringe communities. A lot of people are studying the same set of equations, and then they're trying to say they generalize Maxwell's equations. But I mean, if you can turn those longitudinal modes into being interpreted as bound charge of the ether as well. So, and it turns out that the Whittaker,
there's no argument that there's longitudinal modes in the near field.
yeah, that's true.
It's just, and you don't even have to go to like quantum mechanics and off shell, which is virtual particles and stuff like that. Okay, off shell particles are virtual particles, but
Yeah.
it's like, look, there are
But
longitudinal
these
modes.
equation
The question
motions
is,
change it.
can
Yeah.
you make one of these Bearden style beams? And the answer is either no or nobody knows how, as far as I know.
Yeah. Yeah. Well, anyways, yeah, I'll elaborate it more in a couple of weeks, but I think there's a chance that Bearden was onto something vaguely. But it could be wrong, but there's some mathematics with Whittaker potentials that, I mean, he also talked about the Whittaker potentials a lot, but it's very clear that he didn't understand the relationship between Hertz potentials and Whittaker potentials. For instance, he was obsessed with this O3 electrodynamics, which when you study how the Whittaker potentials fit into the Hertz potentials, you see how it appears as if there's this like three-dimensional rotational symmetry, but there's actually a higher gauge symmetry associated with Hertz potentials that he wasn't looking at. So that that you could make the argument that I mean, it's not what Maxwell said, but you could make the argument that classical electrodynamics isn't finished yet based
Well,
on the
sure.
mathematics out
I
there.
mean, and that would be wonderful because, for God's sakes, we need additional spectrum. And if there were additional modes that were not able to excite or tune, that would just completely transform telecommunications. It would be like $1 trillion thing easily. So whoever can actually make this work on the lab bench, and the only person who's really tried is Hal Puthoff, who has patents on this. Well, I wouldn't say the only person who's tried, but the only person that I know that's gotten anywhere on this is Puthoff. And he's not looking at the Bearden stuff, but at another
Well, I mean,
mode.
Bill Alec is claiming he's on this call and he's claiming to have reproduced some of Tom Bearden's stuff. I don't know. I don't know.
Well, look, all
details, but
you need is like a little it's like a Hertz experiment, like a transmitter on one side of the lab, a receiver on the other side of the lab, and it doesn't excite a normal, RF circuit. It's like it's doing something else. So that would be great. I mean, you'd be a trillionaire if you managed it quickly.
Yeah. Well, I'll let someone else go. There's a couple other hands I see.
Thank you. Can I be heard?
Mm-hmm.
So I have a number of notes. I will not be going into the Bearden Boyd Bushman stuff, but well, first of all, I think we have to put things into historical perspective. More on that later. Firstly, the fact when Creon said that no extra physics was lost, I respectfully disagree, sir. First of all, again, so going back, we have to put things in, when we talk about the quaternions formulation, we have to put in things into historical perspective. Like we are talking about the end of 800s, right? So back then, we didn't have Einstein. We didn't know that the speed of light was constant, right? So at the time, they still thought that the speed of light might be infinite or variable or whatever. You guys, Bill, and also Creon talked about the mathematics, I think, in great lengths. So I will go into I will go more into the details of the physics. So back then, they didn't know that C was constant. So the justification for Maxwell's formulation for the quaternions is that if C is not constant, then epsilon 0 and mu sub 0 are not constant as well. But then Maxwell came around and he reformulated the whole stuff. For a long time, it went in parallel. But then we had the no result. But then we had the no result for the Michelson-Morley experiment, right? So, and then this whole quaternion formulation was lost. Because once we had the new result, that actually paved the way for C to be constant. Once C is constant, epsilon 0 and mu sub 0 are constant as well. So there was no justification for the quaternion formulation. So I think that's sort of we have to put into perspective. One other comment, when Creon said that he had this experience like 20 years ago or so, that's quite interesting, sir, because back then I was living in Las Vegas and I knew a guy at EPA who was a mathematician, and at EPA he actually worked on this stuff, on the quaternions. And also, there was a guy at the university who attended a course on statistics, and I got in friendship with him, etc. He worked at the location at Nellis Air Force, at that famous location at Nellis Air Force Base, which ends at 5-1, Groom no. And he actually used this quaternion formulation for the propulsion systems he was working on. So I think we should be a little careful when we say that no extra physics, that physics wasn't lost, because I don't think so. Although, do we know that C is constant? Well, according to current physics, it's constant. But once there will be an experiment which says that C is not constant, then there might be a justification for the quaternion formulation to come back. Well, I mean, this was in short. I don't know if anyone agrees. This is what I wish to say in short. Thank you.
Well, you hit on some things there. I think it's worth clarifying that now what is called the macroscopic interpretation is for media. But once again, I mean, you can formulate macroscopic Maxwell's equations with or without quaternions. So just because we're revisiting Maxwell's treatise with quaternions. I mean, you don't need quaternions to do it, but you can formulate them with it.
I agree. But like I said, I wanted to put let's put it into a historical perspective. There were lots of stuff they didn't know back at the end of 1800s. So I agree with you that we don't need that right now with current knowledge. That with current knowledge, we don't need quaternions anymore. But back then, they didn't have quantum mechanics. So they probably back then they needed quaternions if C wasn't constant, right?
No, you don't.
No, you don't. Back then, used quaternions initially, Maxwell did, because he didn't know about vectors. It's kind of like the way Einstein had to learn about tensors before he could do general relativity. The math, whether it may have been known by a few people, was not known by Maxwell. Once he learned the math, he rewrote all of his stuff using vectors. And he was smart, and he knew he wasn't throwing away any physics. Now, I'm not saying that there isn't any physics that Maxwell didn't know about, or there may be, we all hope there's new physics that could allow for all this exotic technology, but it's not there in Maxwell's quaternions. It's just not. It's mathematically identical to a single 3-vector field plus a scalar field. Sorry, that's just it.
Yeah, that's right. Yeah, so Gibbs and Heaviside invented vector calculus to get the same physics in the quaternions, but they didn't like working with the mathematics of it. But they also during that time, they also got rid of this idea of having a medium. Maxwell's treatise did actually include a term for magnetic monopoles, so that's typically not included. And then also the way that Maxwell looked at the Lorentz force law is a little bit different, and that got changed as well by the time Heaviside had modified the equations. But you can do either, you can go, whether you use quaternions or not, yeah, it doesn't really matter.
Well, is there a way, could you plug these into a spreadsheet or some kind of computer calculation and just run variations on all terms, right? Like an evolutionary simulation or something, where the end result shows a negative gravitational force?
No, because if you're talking about Maxwell and not anything additional, like, is it David, who's the previous speaker who's been talking about the,
I think David, yeah.
Yeah, I'm David.
Yeah, David. So like what David was talking about is beyond Maxwell, okay? And I'm sure David agrees. If you're talking about Maxwell and Maxwell's quaternion formulation and his later vector formulation, you don't have to run any simulations, because if you're thinking computers and you know about data, you know about objects and methods, or data structures and operations on the data structures, like you could write the data structures as pure quaternions and then the operators on them, or you could write the data structures as 3 vectors and scalars and the operations on them, and you could just swap them. They replace one another. They're the same thing. They're just different ways of doing the same thing. And the reason, one of the things about the quaternions that confuses people, and I think also, was one of the reasons Maxwell probably got rid of them as soon as he could, is because quaternions are actually more general than a vector plus a scalar. Quaternions are more complicated. They're like full-on 3D rotations, and they're non-commutative and all this kind of stuff. And it's like, but that was not a feature. That was a bug for Maxwell, because electromagnetism didn't need all that stuff. So he restricted his quaternions to be this very special subspace of quaternions that didn't have this bug, if you will. And then later on figured out that it's equivalent to a vector plus a scalar. Okay, I think we've done
I have one more question, if I may. So let's say, okay, we can be all cleverer now than they were at the back of 1800s. Let's say right now we don't have quantum mechanics, and let's say it turned out that the speed of light wasn't constant. So if the speed of light is not constant, then epsilon 0 and mu sub 0 are not constant as well. So once they are not constant, could you still reformulate Maxwell's equations in vector formulation? That's my question to
I don't know. I suspect.
So that's the point. That's the point, sir. That's the point.
Oh, fine.
Wait,
if the vacuum permittivity and permissivity are not constant, or the speed of light is not constant, That's new physics, and you probably
No,
knew.
no, sir,
It's not
sir.
new mathematics. It's just macroscopic electrodynamics, and you
No, no,
like
no.
you can just treat it. It's the change of interpretation of known math. Like
Oops, you
we
muted.
understand how to discuss electrodynamics in media. The question is the vacuum a medium, yes or no, right? So
Right.
over time, Maxwell was thinking of the vacuum as being a medium. It wasn't called macroscopic electrodynamics. It's just historically over time, what Maxwell's talking about now only gets used for macroscopic media. So there's the microscopic formulation, which gets rid of the ether, so to speak. And then there's a macroscopic formulation, which is more complicated. And so then the question is, what if this ether actually is real and there is material properties? I mean, that's something you can go into. And that would be just revisiting what Maxwell was trying to say. And actually Heaviside as well, like Bearden crapped on Heaviside for reducing it, but what he didn't realize is Heaviside also generalized Maxwell's treatise, and it was probably Heaviside's most difficult work, and like no one really read it because it was so difficult. So and even Einstein himself said that, like we need to revisit Maxwell's perspective, but like, and everyone moved on.
Well, so if you approach this from the other direction, right? And there are a couple of directions. For instance, the stuff that Drew is working on, Drew and Charlie Bueller, is very different. That's more like T.T. Brown type stuff. But when you because Creon was mentioning experiments, right? And really all we have are lore and legends, and maybe this happened, but we're not sure. But like if you look at something like the Graviflyer or the Searle effect generator, or I forgot his name, Stan Deo's description of, I think, the TR3B or whatever he was calling it. When you look at things like that, you have this common theme of spin and rotating magnetic fields, right? And so that could be some kind of a psychological archetype, but it is interesting. I mean, that takes us back to spin, which is one of the reasons that I get hung up on torsion, probably incorrectly, but is there something that we could hone in from that area? I mean,
I'm
Creon
sorry, Tim,
or
but I
David?
would like to make the notion that I think the reason for this all APEC, I think if you want truly new physics that will take us to the stars, lots of physics are exactly right there if C is constant or not. And if C is not constant, as David and also Creon agree with me, that then epsilon zero and mu sub zero are not constant as well. And again, Maxwell didn't know. I understand you guys. Now we know that C is a constant, so we don't need quaternions. I understand. But
No,
Maxwell,
that's not it. Yeah. It's not that the quaternions are tied up with the speed of light being constant. It's a separate thing. It's just so happens that Maxwell was using quaternions with a
no,
theory that allowed for
I had my
media.
last question, and Creon, I asked my question. If we didn't know that C wasn't a constant, could we still, so that epsilon zero and mu sub zero are not constant as well, then could we still reformulate Maxwell's equations in vectors? I asked that. Creon said
Yes,
he
yes,
doesn't know.
yes, yes,
He
you
doesn't know.
can.
But Creon said he doesn't know.
Macroscopic electrodynamics is taught at universities in
Yeah.
undergraduates, and that's the exact theory for describing what you
I
want.
think I have to.
Did Maxwell know microscopic theory?
Yeah, no, I think I have to. I want to say that I understand what David's talking about here, and I believe he's right. If you're talking about electrodynamics in a medium, particularly a medium which has varying properties through space, then you have to assume essentially a variable of permeability and permittivity and speed of light. But you can do it, and you can do it classically, and you can do it with vectors and scalars, and it's just a little more complicated. However, David, as you probably know, people still publish papers arguing about what the correct definition of the momentum of the electromagnetic field is in the medium.
And Creon brought up something very important here, is the one-way speed of light, because the very idea of what constancy is dependent upon one-way versus two-way speed of light. And that's like a huge problem that people are not understanding, and why it is that you've got like 5 different places that Einstein talked about that we have to give up on constancy. That's confusing to people until you understand this idea of two-way constancy versus one-way constancy, because one is a is basically the that kind of the average, or I don't know an easy way to put it, but it's something that's fairly easily understood, that there's a compensatory mechanism occurring, which was the whole idea behind where we get the kinematics of relativity from the first place. Contraction and time dilation, all these things actually existed before special relativity. We had it was, let's see, Fitzgerald and Lorentz, of course, are most often known. But when you're talking about those aspects of it, those existed where you had a anisotropic constancy. In other words, it would always seem constant in two-way experiments, and the only way to differentiate it would be with a one-way experiment. And what we've got right now is a confusion in the literature even to this day, where Minkowski space-time was kind of added on, and it codifies two-way constancy and ignores let me say that a different way. It codifies isotropic constancy and ignores the idea of anisotropic constancy, which is the two-way effect. And so there's this.
Shiva, and I don't mean to interrupt. Could you delineate? Because again, I'm not a scientist, which every now and then comes in handy. So could you explain what you mean by two-way versus one-way? Because I don't get it, and if I don't get it, probably a lot of folks don't. So.
Okay, I really recommend. There's a video by it's like if you just Google like two-way speed of light, you'll come up with a video, or one-way speed of light, either one. You should probably come up with a video by one of the well-known YouTubers, and it says it's impossible. It's one of the first things that comes.
It's worth at least describing. So yeah, typically you might send a light beam out, have it bounce off something, and then have it come back, and then you detect it. And Einstein, when he introduced relativity, he basically deduced that it's impossible to measure one-way speed of light. It would be impossible to synchronize clocks and move them away from each other, roughly
Yeah, that's the
speaking.
conventionality argument.
The conventional idea is that if you tried to look at the one-way speed of light, like if it just goes from A to B, the idea is that you can't even measure that. And I actually know someone who is a legit physicist who believes that it might be possible to measure it, but that's definitely an unpopular opinion. So
right.
Yeah.
And that is the primary issue, is the conventionality argument that people say, that Einstein brought up probably in the electrodynamics of moving bodies. It actually was brought up beforehand by Poincaré, this idea of whether or not you can actually measure the one-way speed. But here's the issue. We don't care about the one-way speed. We care about a difference in the speed. And that actually is a very subtle and important point about whether or not you can measure the speed is irrelevant if you can measure that there is a difference based upon direction. And that is measurable. Unfortunately, all of the literature has, since Clifford Will started making the difference between Lorentz invariance and and relativity be held to be the same. It's not the same. You can have a relativistic ether theory, and when you conflate relativity with this idea of the one-way speed of light versus the two-way speed of light, and you don't make a differentiation there, then you can make people sound like they are going against relativity, whereas you don't have to go against relativity in the slightest if you hold that there is simply a difference in the one-way speed of light versus the two-way speed of light, and that you can have these experiments that so long as you are only doing two-way experiments, you will never see anything but constancy. But if you can accomplish a one-way speed of light, you will see a difference. And there's a wide array of evidences out there, everything from the cosmic microwave background to there's just so many ways in which it's been proven that this idea of isotropic constancy is false, and anisotropic constancy, as later Einstein understood and talked about in a number of ways, and it's all very confused in the literature. And so understanding this idea, so going back to your question, Tim, you were saying, so how do I understand this idea of the one-way speed of light versus two-way speed of light? So in the original Michelson, and the way in which it was described by Fitzgerald and Lorentz was basically what they were doing with the the change factor was they were describing an illusion. And so it is a perspective illusion that if you were to take an experiment, and so if you've got an experiment like the Michelson-Morley, and you've got light that's having to catch up to a mirror that's moving away, correct? And then it bounces off and runs back the other way really quickly. So what if you then had a shortening that was exactly the amount that would make up that additional time that it has to go? In other words, where you would actually end up not going as far. I've got a paper that has some it's a half-finished paper that I put up somewhere.
And Shiva, if I could, I may be interpreting this incorrectly, but I did several interviews on quantum communications last year, and I got my head kind of turned around. But one of the takeaways that I think I got from that was mechanical limitations, right? Limitations in measurement are not the same thing as fundamental limitations. But in physics, the impression that I've had is that in some cases, and like the argument you were talking about a moment ago with Einstein, it sounds like there's kind of a conflation between we can't see any possible way to measure better than this, therefore it's not possible, right? And I think
it's a little bit like that, but there's some other issues there that you have to really get into the weeds to explain
It's
exactly
about clock synchronization. So if you wanted to measure a one-way speed, you need two clocks that are synchronized, like you're sending light from point A to point B. But how do you ensure that your clocks at point A and point B are actually synchronized?
Okay,
And
it's
it- that
yeah,
it,
that
you know,
that
you have to
what
like
he's
think
talking
through
about.
that.
What he's talking about, that is the main argument against ever doing a one-way speed of light test, is this clock synchronization thing. But the thing is, there are a variety of ways in which you can get around that argument, because part of that, of course, relies upon this hidden assumption that time could literally be different in one place or another, and that is a reliance upon the whole Minkowski conjoining of space and time, which is itself a statement about isotropic constancy. So so part of the argument is this circular. It has a circularity to it. Now, there is some truth to that. I'm not saying that it's false.
Well,
If you have a
assuming
problem
relativity, assuming what he was going for, then
but the thing is, it is an assumption from isotropic constancy specifically. And if you're talking about whether or not you can falsify the whole idea of conjoining space and time, it's actually not a falsifiable concept, because it's in addition to the relativity that previously existed. So, but this, like I said, we can get really into the weeds there, and it's better to have something to draw on. And and I've actually got a paper that's 3/4 finished that we can talk about some other time and get into the weeds of exactly that,
yeah,
the
I would
synchronization
love
argument.
to. Yeah, I mean, if you wanted to, when you're ready, I would love to have you bring that here.
Yeah,
Bill. Oh, sorry.
Go ahead.
Oh, I was going to go to Bill. He has his hand raised, but if
Yeah.
you're not done yet, then
I can make more of a point of it later.
okay, Bill, go for it, sir.
Oh, yeah, Tim, I thought I'd throw this out there for consideration. One of the things that Tom spoke about, he held back a lot. Okay. And I think the reason why he held back was that he wanted a big DARPA contract, okay,
Yeah.
to do his work. So you're not going to get a complete story from Tom.
Well, and
that's
Bill,
why
in Tom's defense, like
Yeah.
Creon was talking about Tom saying that the Russians shot down the Challenger, but there are several well-known physicists that we won't name who make cases like that now for current events. And so the other part of it was everybody wants to connect their work to current events, right? And that would be that might range from the Meg, and he wasn't the only person who claimed the Meg. And it could also, the Challenger thing could be the same way. It's everybody wants to get a little bit of attention, for their work. So,
Well, let me throw this out there, for consideration here. And that is, see, one of the things that Tom spoke about was that all matter, everything in front of you here, all matter is made of trapped electromagnetic energy. That's what Tom said. Okay. Well, what is he speaking about there? Well, to me, if the matter, okay, it's how the electromagnetic waves are trapped. And I think if they're spinning if they're both spinning in one direction, it's creating a scalar function. If the trapped electromagnetic waves are spinning counter to one another, it's creating a scalar function, but it would be anti-gravitic rather than spinning together, which would make something gravitic. Okay, that's to me is what he was, I think, referring to. It's how these waves are trapped together to form a particle, that how it's spinning. If they're spinning together, it's gravitic. If they're counter spinning, it would be anti-gravitic.
Yeah, but that's easy to say. But what do you
Right.
even mean? Like, where is this connection? Hang on a minute. How do you come up with a connection between electromagnetic waves and gravity? Now, of course, there's a connection in general relativity between electromagnetic stress energy and any other kind of stress energy, which is curved space-time, which is roughly equivalent to gravity. But in your mind, I think you're talking about something else. You're talking about some kind of thing with just like radio antennas or something like this, or magnets, and somehow it's coupled to gravity. So where do you get that from?
Well, from the experiments here.
Okay, well, that's a good answer.
Okay, trying to explain a scalar wave.
No. What about experiments that actually show gravity and anti-gravity? Like, now we're talking. If you're talking about experiments that just confirm some model you have in your head of wavy lines on paper, personally speaking, I'm not interested. But if you got experiments that show changes in mass or acceleration from electromagnets,
right. Where you take two magnets, force them together, and you do the drop test.
In terms of Bearden,
where are those results?
Test.
That's really interesting. I'd love to look at those.
So Bearden told me one thing that stuck with me, and I hope this isn't incorrect, but it got me at the time. I was asking him something about, something to the effect of, if you've got these anti-gravity devices like the Searle effect generator, or any number of them, and you've got them, they're rotating, rotating magnetic fields. I said, can't you just substitute rotating fields for the mechanical rotation? And his answer, and other people have said this, but his answer to me was no, because there's a difference between mechanically moving electrons at hundreds, maybe thousands of miles an hour as they rotate, and electrons in wire, which only move millimeters per hour. I think he said something like about a foot per hour. He was saying the movement through space of the electron is important, and that's why the mechanical rotation makes these devices work better. Now, that could be complete BS, right? But it was one of those things that stuck with me. And like, again, seeing the Graviflyer with the spinning discs, or Searle effect, or any of these rotating magnetic field devices, they always seem to have mechanical transport of charge. And that always interested me because it takes me back to what he'd said. So if my thought, I might be wrong, is if this is warping space or something like that, then that warping is more pronounced by the movement through space rather than, just the field itself moving. So that was, again, I don't mean to be critical of Bearden or, Bushman. So with Bushman, the question would be if you could use lens levitation against the Earth without a base plate. Now, he did not get into that I remember, but that would be the question with Boyd's thing. Are you able to do some kind of a lens levitation against the Earth itself? That would probably require applying some kind of a field to the ground, but that would validate his theory,
No, that wouldn't do anything. That would just be an electromagnetic trick like a maglev train. So
yeah. Yeah, I mean, it wouldn't be a true gravity thing. It would still be an electromagnetic trick, but that would validate his thing for how UFOs fly. That was what he thought.
Oh, I totally disagree. You can levitate magnets on other magnets, like in a maglev train. If you put a magnetic field in the ground and you have a magnetic field in your train, it will levitate. No UFO anti-gravity required. We need something better.
Yeah.
The one
I
thing,
mean, oh, sorry, go ahead.
the one thing that Bearden said that made me curious was this idea that you could have scalar wave interferometry, and he talked about Whittaker potentials, and I just found it interesting because Hertz and Whittaker potentials aren't very commonly discussed, and when I started studying them in more detail, it seemed like there is this argument where the Hertz and Whittaker potentials might be geometrically aligned with the metric tensor in general relativity. And it's also curious that interferometers are used to detect gravitational waves. So, Bill, I don't know if you can elaborate on what Bearden said about scalar wave interferometers. Have you done any experiments with those?
No, I haven't. If you look at some of the work of John Hutchison, where he sets up, his Tesla wave generators, but I haven't seen what his actual configuration, what it was. But I know he was using two Tesla coils in a configuration that would create the scalar function that would levitate things.
Well, I would
He has a
start
lot of video of that.
I would start with to test something like that. I would try and shield it from RF, right? I think Creon mentioned that. Try and do something really simple, like Morse code communications. And if you could do Morse code because that's minimal power, right? You don't have to levitate any. I mean, the barrier to entry is about as low as it gets. So you'd have your scalar antennas presumably in some kind of a Faraday cage, unless that shields them. But if it doesn't, put one inside the Faraday, one outside the Faraday, make sure that there's no RF reception. And then I think it could literally be as simple as Morse code, or like, are you able to send a beep from inside to outside? And because then you can build off that, right?
Now, how that works in theory, that's probably where David comes in.
Yeah, I mean, that's the problem. I can put math together, but then it doesn't mean it's in the real world.
Hutchison, one thing I noticed about Hutchison, probably really basic. When the metals melted, that jellification at room temperature, right? Especially those aluminum bars that everybody's seen online, they almost always seem to start in the middle, which would indicate that there's some kind of a resonant waveform that's peaking there, right? That I think that would be the interpretation. So they're acting like an antenna, but that would make it some kind of an RF thing, right?
Yeah, except the ends of even if they were just bulk heating, the ends of the bars would radiate more. They have more surface area, so it's hard.
Yeah, that was just something I noticed. The ones where the Hutchison effect, if you see it, it starts to crack and peel up in layers, and then it gets all stringy. And what I noticed was, having looked at those, most people miss it because he only shows you the pieces. But when you see the pieces together, it's like, here's where the bar was. It started in the middle. And I've seen a couple of old videos where it actually it starts to, you can see it starting to peel and lift in the middle. So
yeah,
just to put that out there.
But there's
that's when it merges with wood and metal. And I have to say that the equations are meant to define the physical experiments that we do, not the other way around.
I've touched the wood one. I've held that one. He had it wasn't giant, but he had a piece of wood in the metal, and it was unburned, and it was still wood. You could scratch it with your fingernail, and I mean, I don't know the exact.
Wow.
Hey, I'm curious if you guys would like to hear a novel idea of what gravity is and a way to connect it to electromagnetism.
Sure.
I'd sure like to hear that.
Okay,
Wait, was that Jeremiah? Jeremiah was lurking?
Yeah, I was lurking. I'd like to hear a novel idea of gravity. I'm looking at the one I just wrote yesterday.
Okay.
So I'd
Well,
like to
and
hear
let me apologize again if I've offended anybody in the last hour or so. But yeah, go for it, Shiva.
all right. So kind of the basis for looking at ether, whenever you try to trace history and stay as close to how ether evolved after relativity, then you come to a Courserac continuum, and now that goes back to Kelvin and McCullough and the idea of rotational elasticity. But let's say it's a particular type of continuum, and one of the things that you can do with this model is you can model superfluids. And so if we assume for a moment that the idea of the ether that is correct is that it is a superfluid and behaves like a superfluid, one of the things that happens in a superfluid is that it spontaneously creates these vortex filaments. And basically the reason why vortices appear in a fluid is because there is if you think for a moment, like one of the things I like to bring up to people is when you look at two waves, like passing through each other in some substance, and when they cancel out, they still reappear afterwards as they're going through each other, right? So obviously the energy didn't disappear and reappear. What happened to it? It became rotation, and so there is something known as wave vortex duality. So in other words, whenever you have waves in a fluid, you also have vortices that form. So since there are vortices, there are waves in a fluid, and a fluid like ether, you're going to have all of these filaments everywhere, just like we would expect in a superfluid. So now, taking this idea of vortex filaments as a component of what's happening in the ether at all times, then there would be a general vorticity to the ether. If we take this idea that the more energy that is in it, in other words, the more kinetic motion that is not in a straight line, but in a in a rotational form, the more you're going to have the more of these filaments. And so the idea behind extending the Courserac continuum and those things of that nature is that when we look at the lines of the flux tubes, the lines of force, all of those things are references to these vortex filaments, and that the rotational speed is sort of a measure of energy. And so whenever you have more rotational energy in an area, there are going to be more of these vortex filaments, and that would be what gravity basically is in one form. But then the other aspect of what happens to a fluid as it has more of this rotational energy and more of these vortex filaments. And that is where, instead of where we made this mistake in ether theory going back 200 years ago, to where we have have increased density inside of an actual physical object that causes the speed of light to slow down, we can instead have a reduction in rigidity, and that would have the math would be almost exactly the same. There's just you just change increased density to reduced rigidity, and it works exactly the same for the deviation of light, in a variety of things. Anyway, I'm getting a little far in the weeds here, but the point here is that as you have more of these filaments, then the rigidity of the ether changes. And then what you have here then is a system by which whenever there is more gravity, there is basically the way in which the ether can, by having less rigidity, slow the speed of light. And so this is a variable speed of light idea. And then when you were looking at a magnetic field, and I recommend that anyone interested in this there's something called, you can just Google magnetic warp circles, and there is a video there that has this great way of visualizing magnetic fields by using a Heal-Shaw plate and a ferrofluid, so that you can actually see all of these various filaments and the very structured way in which magnetic fields create these vortex filaments. So basically what we're talking about here is that that magnetism is the organization of the vortex filaments into small closed loops around, whenever you have a magnetic field, whereas gravity is the bulk vorticity of the medium itself. And so this matches up with things like, for instance, whenever you can levitate a frog in the bore of a 3 Tesla magnet, or what is this connection between magnetism and gravity, and it would be this presence of vortex filaments, and in one case it is an organization that is more local, whereas the other is a bulk overall vorticity, and that's where you have this exchange between the two. So that's the idea, that extending ether theory using what ether theory was, and that actually matches with, like, for instance, one of the people that helped Einstein in developing general relativity a tremendous amount was Hilbert, and he based his ideas in Mies' four-dimensional version of McCullough's ether, which is a rotational ether. And you can track all of these ways in which we were developing a form of relativity and gravity, etc., along a certain line, and we just kind of got a little off track with losing the connection between the math and what the math represents, and knowing that there is this bifurcation point right there at relativity, where the initial, what I was talking about earlier, that there is this one-way speed of light. The initial calculations of relativity were specifically to describe how a moving medium would alter objects, and then alter your perception of the events. In other words, it was the time dilation and length contraction are entirely functional in a medium, and that should be the most people who have been taught constancy, that should be very strange to them if they haven't really deeply dug into this. I'm sure there's a couple of people on this channel that actually understand how relativity can still work in a medium, but there are these levels of education about relativity where at the first levels, the idea of relativity functioning in an ether is absurd to you, is what you're taught, but it's actually not. It's where relativity initially came from, is a description of the way in which ether in motion would affect light in experiments like the Michelson-Morley. So anyhow, that is a quick and dirty idea of how gravity and magnetism would be related according to this bulk vorticity, and therefore the frequency and density of the vortex filaments being part of the change in the rigidity of the medium.
Well,
Yeah.
yeah. Phil, did you want to go?
Yeah, I just want to say quickly that the one-way speed of light is exactly what I talked about at the beginning with the supernova explosion. I sent a link of the interview of the guy who explained that there's a 2 seconds difference between red light and violet light, or frequencies of the different frequencies. So that's the perfect example of a one-way speed of light. And the measurement devices are, it bypasses the uncertainty of the measurement devices by a great factor. So I don't know what can be more obvious than that. And also it's extremely difficult to convince. It's like mainstream people who were trained with mainstream notions, but Creon is open to experimental evidence, and I posted all the links of my experiments that prove that energy density, energy potential created by any form of energy density, including magnets or gravitomagnetic and energy density and all that, it creates a deflection of light with an interferometer. So I've been through that already, so I just want to speed things up here.
Okay. Well, Phil, thank you. Okay. Well, guys, we got probably about half an hour left. Let me see. Yeah, I like I know with what Shiva's talking about with kind of the superfluid model, I really like the conceptual approach of that. I mean, I don't know how to interpret that, but for me, spin is really interesting. I've been intrigued by spin just because I see so many references to it, you know? And so vorticity in the ether, maybe that's related to it.
I
Yeah.
actually agree quite a bit with the vorticity in the aether and spin. In the model that I've been working with, the one that I'm designing devices around, gravity is a fundamental expansion of the quantum vacuum, which is in this model comprised of a self-structuring sea of particle-antiparticle pairs. Basically saying that you go anywhere, it's filled literally with particle-antiparticle pairs. But in this particular model, the difference is these are not random pairs that pop in and out of existence. I believe that's a measurement error. These are pairs that are actually, in the classical definition of a pair, two bound oppositely charged particles that have a finite radius, and they have a certain radii size that causes them to have an information horizon or a boundary condition. And so one of the conditions is that they can absorb an electromotive force, and their radius, besides just the normal polarization or twisting of their dipole moment, which would carry a photon or an electromagnetic wave in the classical sense, the electromotive force is going to give them both a twist and upward charge, which will cause their radius to expand. And because in this model, space-time itself is actually made of these organized particle pairs, which do self-organize into a more structured set, then increasing their radius decreases the physical amount of matter in the background space-time. So less particle pairs equal basically a matter vacuum, and it's for this reason that we end up with the emergence of the gravitational force acting very much like the pressure, where you have lower spin, higher density particle pair space, pushing any intermediary matter into the lower pair density, higher energy particle pair space.
So, I mean, if I could build off that, this kind of going back to the graviflyer and the very, very loose hypothesis that I had, but this idea of if you've got these vortices, you have things like that, the intensity of modern electronics and power sources probably isn't going to be enough to directly do very much. And I believe, and if I'm interpreting this right, it's been a long time, and I'm not a physicist. From what John had said, and this comes from him and James Coram, the shear effects where these boundary layers meet, right? So if you have two, for instance, you have two vortices, they're spinning in opposite directions. The intensity that we can generate from our power sources probably isn't enough to do a heck of a lot in most cases. But where these two meet, you get a very thin shear layer, and that is where these nonlinear effects can happen. If I'm interpreting.
Yeah, and that can happen near matter because you've already got a tremendous amount of energy there, which is why I feel like, for instance, what's his name? Doggone it, it's slipped my mind. But the fellow with the CIA talks about UFO physics.
Jack
Sarfati. Yes, I feel
Yeah.
like he's telling about 98% of the truth and purposefully confusing things for about 2%. I genuinely believe he's a plant, but I think he's also providing a tremendous amount of true information. And so the idea of behind metamaterials is that if you already have a tremendous amount of energy in a very small location then these effects at a quantum level very near a metamaterial could basically create a sheath where you have changed space-time in an entire sheath around it, because you're just joining together the effects at that quantum level on the metamaterial. And so it actually does sort of make sense from my perspective as well. And by the way, I don't know who was speaking because they didn't have their name on the interesting
sorry, that was me, Jeremiah.
That was Jeremiah.
Yeah. Showing us break the limit on here.
Yeah, it sounds like you're actually speaking kind of an analog to what I was saying in a certain way. It sounded like though you were more based on particles. I tend to think that we need to think more in terms of continuum mechanics as right now. Well, I mean, I think that you kind of have to have both, but I think that a shift towards continuum mechanics will help people understand it at a higher level, and then you can come back down to a particle level and make sense of what we're what we understand now in a different form.
Well,
And so that's why
now,
I focus on continuum mechanics.
so what would continuum mechanics are you talking about geometries? Because that's relativity is primarily geometries, right? Like the Lorentz transformations.
Yeah, it's in other words, I'm looking at things from a whenever you're talking about continuum mechanics, you don't have as much in the idea of particles. In other words, whenever we're talking about a phonon is my favorite example. A phonon is a thing that is functionally real, but not physically real.
Yeah.
Now, this is something that everybody knows about phonons, is that it is a very valuable thing that you can calculate. There is a sort of realness to it, that there is a real effect, just like there's a realness to a wave out in the ocean. You get hit by a single wave, but then without the water, does the wave really exist, and can you think of a wave as an existence on its own, since the fact is it's just what water is
Well, you've
doing.
nailed the crux of this difficulty here, and this is why I don't think in purely wave mechanics, and why I consider an actual particle C, because you cannot have a phonon absent the medium, since the medium is literally responsible of all its properties and mass of carrying that phonon, and literally a transition between one medium to the other is still carrying the same phonon energy. There is an impedance match between those two, and you get either wave deflection or transfer.
Jeremiah, think about, okay, if I'm not mistaken, if you have a high enough particle velocity, right, from a collider, or electron accelerator, and you send out your particle into the void, if I remember correctly, a single particle can disappear and you get like a proton, or you get like a positron and an electron out of it, right? You can create antimatter from particles doing that, right? So
into the void, it becomes extremely unlikely, because you'll never get the necessary curvature for that magnetic curl to actually split the particles apart. The only way that you can get a particle pair to pop out of the vacuum is if you increase the spin of the pairs that are already there to a sufficient point where they have effectively absorbed 1022 kilo electron volts of equivalent acceleration potential.
Well,
so
the reason I mention that is so particles themselves probably can't exist outside of the background. So a phonon. So I think that's kind of where Shiva was going.
I think there's a value. Here's the thing: is so everything in the past 100 years has been about particle physics. So we still need somebody who is thinking in terms of both continuums and particles to ever make a bridge between our current physics and any advancement of physics that returns to continuum mechanics. So in other words, I'm not in any way disparaging what he's saying, and I love the fact that there is a level of analogy there. I'm just saying that there's a point at which I want to get people to think in terms of continuum mechanics, so you can see things like the idea that what point, one of the papers that Poincaré gave back at around the I think it was around 1903, is he called it the end of matter, and the idea was that there is no such thing as matter, just like there is no such thing as waves, and that basically, and that is the whole vortex model of the atom, et cetera. So what you've got is these threshold events that create matter. And so like in an ether, from a perspective of ether, that would be whenever you have a vorticity that reaches a certain threshold, then you might have a cavitation in the ether itself, where basically it's a phase transition in the ether itself. And that's where you have both massive particles as well as electrons, and so they have a particle-like nature. But the reason why they behave in a strange quantum manner is because they're dependent upon the waves interaction with the vortex. In other words, at the point at which waves interact with all of the vortex filaments, or where we are seeing this particle-like behavior. But the reason why those particles do not seem to have a real location and how they're so dependent upon the wave is because of this emergent combination of two things. In other words, if you have just a wave, you're not going to rip open the medium. If you have just a vortex, well, that vortex has to have something that causes it to spin fast enough to cross the threshold that'll rip open the medium. And so that's why you have this wave particle interaction going on. But then the idea, then you've got to think in terms of solitons, and a wide variety of issues come up when thinking about particles that they're still useful. In other words, you can do engineering based upon phonons, even though you could argue they're not real, but we do engineering based on them. So it's like it is a concept that is valuable because it has to do with these thresholds above and below, and transition points that are real in nature, but we are abstracting them to give them a particle nature that allows us to deal with them mathematically, allows us to have units. Because the problem with continuum mechanics is this problem of units. When we're in the way in which we use mathematics is not we need units basically in our mathematics. Now, going kind of to the side here, I think we're about to overcome that with the way in which we do computation. But that's a whole other that's a whole other subject. But the point is, right now, to be able to have a model that will speak to all of our work that we've done so far over the past century and say, well, what's happening here? Why do we have what's going on in a particle accelerator when we know we have all of these ways of up and down quarks and charm quarks and all the zoo of particles? What is all of that? Well, what is all of that is specific unique behaviors of the medium that are either crossing thresholds or linking together two different things that are very reliable. And so if you look at the medium, just kind of going back to, you're talking about spin, and spin itself, you have to think of spin in terms of spinors, which are not conventional. Like whenever you're looking at a typical vortex, you're thinking of it in a very very simple way, whereas a spinor has a way in which everything stays connected, like the belt trick and all of that, and that would be necessary in a medium that is very mechanical. In other words, it's very like particulate-like, and so there may be another layer of particulate, at the Planck scale, where the ether may have Planck scale units, but there's a point at which you have to kind of call it and move upward from there. So sure, maybe there are Planck scale units, in the ether, and that'll be valuable for us to know what they are shaped like in the very near future. But going back to the idea of particles as we typically think of them, they're nowhere near the Planck scale. We're talking about all of this, the zoo of particles, and then there's ones that are very obvious and massive that we can image. And how do those things exist? How are they created? All of those things actually can fit together in this version of ether theory, which is, like I said, when you go based on where was physics going and how did it, what parts of 19th century physics really truly utterly gave birth to our current physics. In other words, what physics from then are completely underpinning, and our current physics are actually dependent upon, even if they've forgotten the connections, because there are connections to these older aspects of physics from the 19th century that a lot of particle physicists are not aware that their work has this conceptual lineage that is dependent upon the mathematics that was developed for the ether. That was and just a wide variety of things like that. Going back to Kelvin in particular is one that was interesting, because he actually made the idea of a rotational elasticity. That was one of the biggest problems. There was people were ridiculing Maxwell for having the advancement of Maxwell's theory kind of had this non-physical feel to it, and people were like, well, that can't be real if it's non-physical. In other words, they were very caught up in ideas like that, and actually Kelvin in 1889 gave a paper that proved the idea of rotational elasticity, and then this kind of underpins and fixes McCullough's rotational elasticity in ether, and all of the whole field concept is itself based upon rotational elasticity. And a lot of people are not aware of that conceptual lineage of the field concept. And so it's just, whenever you advance these ideas, there's things that sort of fall out of them when you understand the history of the greats.
Now, thank you for an incredibly detailed dissertation, Shiva. Looks like a few people have been waiting very patiently with their hands up.
Yeah. Let me go to Michael. Let me go to Mr. Boyd.
Wow.
Well,
my mind is blown. That's all I can say. Ether is back.
I think ether has been back for a while. They've just been calling it different things. Quantum foam, to me, that seems like ether. I mean,
so Shiva, this whole idea of the little toroidal universe, is that sort of what you're suggesting? I'm trying to think in my mind. So you have your toroid, and it's pulling down. Okay, it's a little parabola pulling down, and then what comes out the other side is a bubble, right?
Well, I'm going to ask Shiva, actually. Let me jump in. I'm going to ask Shiva if he wants to speak more on this on June 8th, because I have an open spot. So I'm going to
Okay,
twist his
well,
arm and
ask him.
say,
Yeah,
Both ask him.
I should be able to. I'll have to. I'll check my calendar and get back with you. I'm actually going down to Contact in a Desert, and I've got a couple of days after that. And so but I think that your timing there is still good. So yeah,
okay.
that should be able
Well,
to do that.
skip contact. You can shouting match on Zoom instead of Contact in the Desert. How's that? We're way more fun.
Yeah. Let's forget about it. All that money I put into it, I'll just take a loss.
So my
Yeah, just
yeah,
let me
you
know.
had a question. Okay, sorry. So the idea of toroidal vortex atoms, you actually have to kind of get into cymatics and the and cymatics. The funny thing is I recommend everyone go to John Bush's page, and I actually bought a better URL for him, and I keep forgetting what it is. And so it is John Bush at MIT has been doing experiments on the walking droplet, so that where basically when you drive a bath to a certain uh, frequency, basically what will happen is a millimeter sized droplet will bounce on the surface in a chaotic fashion. But the thing is that chaotic fashion exactly mimics quantum theory. And so let's see, hydrodynamic quantum analogs is what he used to call it, but now it's doggone it. I bought the URL for him and I
losing
keep
me.
forgetting it.
Shiva, you're losing me.
Okay.
I just heard a
What I'm going to
lot
get to here is whatever you're
a
talking
lot
about.
of salad.
Yeah. Okay. So well, I'm just referring you to something that's going to prepare you. In other words, there's
let's simplify it. Okay, you're draining your bathtub. When you pull the plug, it goes down a little spiral. What comes out the other side? It's not a pull force,
okay.
it's a push force, right?
That's a two-dimensional vortex. So what you're thinking of is like a two-dimensional vortex versus a three-dimensional vortex, which would be like a torus. And so so what is it that maybe you're trying to ask something in particular, and I feel like you're maybe trying to load a question. So let's hear the loaded question.
No, it's not a question. I mean, it's what I observed in my experiments with nanogravity is that the pushing type is like a balloon, and the pull type is parabolic force.
Okay, here is one of John Bush's pages, and actually there is a Wikipedia for it. And here's hopefully you guys can see this, a super walking droplet.
Right. And the one of my favorite versions of this, you've got all these ones in which they're locking together, and you've got everything from Bose-Einstein condensates to quantum tunneling, and basically every behavior we see at the quantum scale, we can see at this macro scale, because basically this is the way in which chaos theory shows us a deterministic evolution of a droplet's interaction with a wave, with its own wave field, and because of it has this feedback loop effect. That's why you've got all these complex evolutions of things. But to make it simple, how would this relate to a particle, which I think is what you're getting to, and there is a way in which you can see that a wave and a vortex being dual, in other words, meaning that as waves go through each other, there are these necessary mechanical interactions between the medium trying to go through itself, right? Because if you're thinking in terms of medium moving, that's what a wave is. It's a behavior of a medium. So as like when you think of the two waves who are headed towards each other, and then they go through each other, and for a moment they cancel out. What's happening in the cancellation? There is a orthogonal vortex or multiple vortices that form. So now when thinking of in terms like this, like
mass is changing, correct?
I don't know that that's relevant at this point. Actually, if you don't mind bringing up a video real quick, if you
go
look
for
at,
it. Do you want to bring it up? Or
let's see if I can find it. Water sound images on YouTube used to bring it up. Let me see if that still does it. doggone it, it's gone there.
Because
Yeah,
I
I
don't
can
know if
find
it's
it.
the right one.
Let me find it real quick, and I'll you
Oh,
guys can talk amongst
sound
yourself.
and water. Let me see.
Yeah, there are a variety of ones here, and
I got
this is called
YouTube it.
cymatics, but it's actually it's called by a different name in the
Water
rest of
cymatic
physics.
sound. Okay.
Mhm. Yeah, and there's a variety of ones there, but the point is, in a single droplet, if you were to, and I'll show you this here in just a minute after I let you guys get back to talking, and I'll just go try to find my stuff and show you. But one of the things that happens in a single droplet, if you vibrate it at the right frequency, is it will start to have these natural formations of geometric figures. And the reason for that is because there's an interaction between the vortex motion inside the droplet, inside this spherical entity, and the waves resonating inside it. And then that creates these structures that are basically you have multiple points that are vortices, and so this is how you would understand all of the various effects of that we think of as like electrons, and that is there are these waves passing across these structured vortices that are dependent upon resonance that will they themselves are not they're not perfectly stable vortices, so you're going to actually see these points where they're going to pop up. Yeah, that's a fun video having to do with cymatics. And so whenever you're thinking about how an atom is formed, it's going to be this combination of vortices and waves that are resonating inside of a single cavity, a spherical cavity, and that's where you're going to have the things like the appearance of electrons, and that is the kind of the basic extension of the idea of the vortex atom. And so it is a toroidal vortex, but that vortex, it has a set of waves that are resonating from the center and out to the outside, back and forth. So let me find that video that most demonstrates like a d orbital real quick for you, and you guys can continue talking. I'll show that to you here once I find it real quick.
Thank you.
Okay, and we got, I think, probably about 10 minutes left. Why don't I go to Bill really quick? Bill?
Yeah, Tim.
Mhm.
Yeah, I thought I'd throw this out there. Jack Sarfati, I mean, he's interested in the UFO phenomena, but his viewpoint seems to be that it's the skin of the craft that's creating
Yeah.
the anti-gravity, and that it's using a special ceramic material. Okay.
I'm not sure if he specified, I don't know if he specified what he thinks the material is.
Right.
I think, yeah, I would agree with you on
Right.
the skin. I'm not sure
Yeah.
if he specified. I think he's kind of left that to folks who do engineering to kind of figure out what he was saying, if I remember correctly, was the speed of light is different in materials than it is, and so you can use that to overcome some of these mathematical barriers that, prevent warp drives normally.
Okay. Yeah, that's all that I wanted to mention here.
Okay. Abby?
Oh, sorry. I was just asking, I was gonna say that this idea that ether is shows the Wilson Morley-Wilson experiment. It does not show that the speed of light is constant. It just shows that the movement through ether does not change the speed of light. It doesn't show that the ether does not exist. It does not show that the speed of light is constant. It just shows that the movement through the ether does not change the speed of light. That's one thing I wanted to say. The other thing I want to say is that there is a good correlation between the vortices you are talking about and A vector inside currents. So this is I forget what it is, what's it called, but it goes in the same direction as the currents, basically, in the Maxwell's equations. but it's a field from which the magnetic field is derived. And therefore we can use that to derive spin, which does not cancel in the same way as the magnetic field itself. So if you have heard about the bias effect from the patents that are filed by the U.S. Naval Intelligence and all about this the
Yeah.
surface,
Yeah.
the
And
surface being modified so that the surface just above or below it is the space is modified in order to allow for non-gravitational effects to occur. Anyway, that's what I have to say.
okay, well, thank you. Thank you.
Thank
Yeah, so I think we've got about 9 minutes left, and I'll close things down then. And we've done pretty well today. Again, my apologies, Bill. My apologies if I've offended anyone. I'm not trying to trample on people's heroes, but I think we should just be realistic about everyone in the past. They were human. They did things right. They made mistakes, and and the best that we can do is build off of that moving forward.
Can you show that video now? I dropped it in the chat there.
Oh, yes.
Yeah, they're called Faraday waves. So like cymatics is also known as
Okay.
Faraday waves. And
hold on.
all right, no
So
problem.
it's starting. I have to zoom up.
So yeah, this is a great one of the best visualizations I've ever seen of how Faraday waves and this is just a droplet of water.
29 minutes long now.
Well, you don't have to go through all of it. I'm just going to show the beginning part. So here he's gonna start trying to create a standing wave in the droplet. Like I said, there's just a droplet of water. When you reach the right amplitude and frequency combination, it requires both. Then what you're going to have is a sort of a stable figure. And then what's going to start appearing here, if you look closely, is you'll notice the bubbles inside of it are going into vortex motion. Now it'll come out where you can see it a little bit better here in at about the 1 minute mark. But you should start to be able to see how the bubbles there are moving, and they're not moving in the direction that the waves are. The waves are going from the center and outward, and there is a toroidal flow of the fluid itself. So there's this wave vortex combination that's occurring. Now, this is going to have a very simple set of vortices in here, and they look very much like the d orbital, and you'll see it just a moment. It's about to get to the particle version. Here we go. Yeah, so here he has some particles, and you can see there's sort of that figure 8 of the d orbital, and then there's the little lobes on the sides you also see as well. And so that's where you're going to have the high probability of finding an electron. Now, why would you have a high probability of finding an electron there? Because the creation of a locus of an electron happens from the wave passing across the vortex, and the point at which it is where it is spun up the greatest speed is where you're going to have an electron appear. So this is kind of a basic model of how vortices lead to atomic structure. And now if you just kind of fast forward, they're going to see a bunch of other stable structures that are created. There's an instability when he hits the wrong frequency, and then you've got, go ahead and play that for a second there. And here you see like your regular hexagons occur, octagons, any structure you want to create it's only necessary to hit the right combination of frequency and amplitude for that droplet, and you'll end up having, see, he had an instability there because his frequency or amplitude got off, and so that would be the way in which you would describe the toroidal vortex atom model is based upon these mechanics that we see at a larger level. Now, of course, that was all I really wanted to show here. You'll see all the other ones, it's in different speeds, and it's a fun video that talks about cymatics in general. But John Bush at MIT is who's going to tell you a lot more about how we have this model that is basically in 2 dimensions. Now, whenever you're talking about the walking droplet, there is an actual droplet that is bouncing repeatedly on the surface. So there is gravity is involved there. And so where is this, where's the analog of the gravity that's causing the droplet to go up and away and come back down? Well, it's storing it in the energy in a 3-dimensional look at it. You would look at, like, for instance, I don't know if you've ever seen a gunshot underwater, but it opens up a void and then that void collapses. And so that's where the restorative force of the droplet is not an up and down along a 2D surface. When you convert it to 3 dimensions, basically there are these open cavitations that are storing energy in the medium around them and then close back up, and then the energy of that closure then rips it back open again. And so there's just a repeated cavitation. This is what you actually see in any kind of single bubble cavitation that you see in, like, explorations of sonoluminescence. You'll see that same sort of mechanism occurring, where the repeated cavitation of a single bubble as it turns inside out repeatedly. And I find it very interesting, though it's not directly related, that you have sort of this fusion event that occurs in sonoluminescence, which is why you have light coming out from those bubbles. And it's just because of the way it can concentrate energy down to a point, and that's how you actually have the fusion events giving off light in sonoluminescence, if you've looked into that at all. But what's interesting there to me is the difference between energy that is the conversion of one kind of energy into another. And so whenever we're trying to look at, how would 0-point energy work, how would you exchange one sort of energy for another, and we actually kind of see that in sonoluminescence. So anyhow, that's all I wanted to talk about, is just to give some little hints there, because this could go on forever. I don't want to take up too much time.
Yeah, it looks like Gerald and then Jim Marson both have questions.
Yeah, sorry, I was muted.
Subject, so let's
Yeah,
jump
Gerald,
over them.
go for it.
Hey, everybody. Just kind of a quick question. It may seem a little bit dumb, but just saying that out loud. I work on electromagnetic vortex coils, and I say that because I could show many experiments that show that there's a vortex going on. Now, when it comes to sending a wave at itself and it canceling out, my question is, do you mean when you send a wave at itself, is it 180 degrees out of phase, in the sense where it's like a mirror image sending it at itself, or are you just sending 2 electromagnetic waves that you've created with 2 separate coils? Like, maybe I'm not putting the question quite right.
Yeah, I think you may be putting more detail in it than I intended, and I understand that is an interesting idea that you're thinking of there. But I was talking about more just like, if you're just looking at ocean waves, for instance, and any kind of just typical waves when they are counter propagating and moving towards each other, and you'll see them, actually cancel out for a moment and then not disappear. In other words, the wave then reappears after it has momentarily disappeared. And so you have to ask yourself, what recreates the wave? How does the wave persist during that destroyed period? If it is destroyed, why does it then reappear? Well, the reason it reappears is because the fluid that is carrying the wave, the behavior of the fluid has changed from a simple type of wave to a rotation in the fluid. So it is storing the energy of the wave in a rotation temporarily, and that is how the wave then reappears after the destructive phase. And so understanding this idea of wave vortex duality is extremely important to any idea of ether physics.
That's really interesting, because the coils that I work with, they're designed in geometrical forms, were based on geometrical forms, and they're 180 degrees out of phase. When I send 2 separate signals through them, I actually get a multiplication factor that's insane on the outside. So it just may go to your theory a little bit. It's just very interesting what you said.
Yeah, when you have go ahead.
Oh, I was gonna say I was gonna go to Jim really quick and then probably close things down. But yeah, Shiva, go for it if you want to finish up.
I was just going to say, so anytime that you're dealing with destructive wave interference, they're basically, you're going to have, if the ether is a fluid, and that we're assuming that it is a fluid, then you're basically going to be changing things into a rotational form, at least temporarily, and then that rotational form, if it interacts with some other rotational aspect of the ether, like the various vortex filaments of, that you have in magnetic fields or in gravity itself, you're going to have interesting effects that are going to appear, though they may be transient.
Awesome. So let me do this. I'm actually going to stop recording now. So I want to say thank you for coming to APEC open mic, and I'm going to keep things going. So Jim, don't panic, but we're at 8 o'clock now. So I want to keep us on schedule for that. So this has been APEC open mic for Saturday, May 25th, 2024.